Hi, hope you've been enjoying the course so far. We're going to switch gears slightly in this video and introduce the concepts of object classification and object detection. Then we'll talk about some techniques for teaching a machine to do both. When we say object classification or object detection, what do we actually mean? And what is the difference between them? Classification is the task of defining the class of an object, what type of thing it is. For example, you would look at a picture of an apple and instantly recognize it as an apple. Detection, by contrast, is the task of defining where in an image that particular object is. Again, if you looked at the picture of an apple, you would immediately know and understand where in the image the apple is. Now, while these tasks are incredibly easy for a human to do, they are challenging to write a simple program with fixed rules to achieve the same. So, we turn to machine learning and artificial intelligence techniques to provide us with a solution. Let's introduce some terminology we will need for the rest of this course by looking at actual examples. You might recall our image of tomatoes from earlier videos. If we are to classify an image based on what it predominantly contains, we might assign the class fruit to this image. Tomatoes are a fruit. Depending on how finely we wish to label our classes, we might decide that saying this is an image of tomatoes more accurately describes the image. But this image contains more than one tomato. We might want to identify each object in the image. We might wish to know where the tomatoes are. This is called object detection, classifying objects within subregions of an image. Here, we can see the object at the top left of the image looks like a tomato. It could also be a red pepper. We're not entirely sure. Our level of confidence here is important, because often we might think an object looks like an item from a few different classes. Usually, in these situations, we pick the class with the highest confidence metric associated with it. If we have only one confidence metric associated with the object, depending on our application, we might even choose to disregard it if the value is very low, as it suggests doubt. If this is the case, we've decided to take classifications based on a threshold. That is, we only use object classifications where the confidence metric from the classifier is above an arbitrary threshold amount that we have decided upon. So we continue looking through the image identifying objects, where they are located, which we describe as a bounding box, and what they are, their class. The bounding box will typically be something like top left, X and Y pixel coordinates, and a size, width and height. We'll end up with an array or set of object detections at the end of this process. It is very useful to be able to identify not only objects in images, but also their locations, as we have already discussed when describing real-world applications of computer vision. But our rectangular bounding boxes are a bit coarse, a rough approximation of the location. We can actually get more accurate boundaries through the use of what are called deep learning techniques for image segmentation. We'll talk more about these later in the course, but for now, in this example, we are going to show how we might segment more accurately where the tomatoes are within the bowl. Depending on our needs, we might also classify everything not a tomato as background. What we have in effect done here is create a map that individually labels each pixel in the image to its most appropriate object class, based on our confidence metrics. Current state-of-the-art techniques are not only able to label individual pixels according to their class, but they simultaneously can assign a pixel to the most appropriate instance of that class. This is called instance segmentation. Okay, now we understand what these terms mean. How do we implement them on a computer? You've probably seen from the earlier videos on image processing that it is quite difficult to develop hard and fast rules that will work for all objects of the one class, let alone different classes. Can you imagine trying to write down such a set of rules? What about a different approach? Instead, we'll teach the machine how to do what we want by showing it lots and lots of examples and let it learn to figure out what we are looking for. By learning, we mean we have an algorithm to progressively improve the machine's performance on its specific task through using this training example data. This is called machine learning, and it's a category within the field of artificial intelligence.